All right, hey everyone. So today I'll be talking about training a vision transformer on a relatively new piece of Nvidia hardware called a GH200. It's a Grace Hopper 200. I was able to get access to this model from the Nvidia launchpad program. So if you want to get your uh, hands dirty for free, without paying arm and leg for a huge GPU. This is an awesome way to go ahead and do it. So I just wanted to uh, just build a quick video to talk about some of the hurdles that I ran into while setting up this system, some of the cool tools that I was able to discover from NVIDIA that helps you understand how the GPU is performing. Then I'll dive into the data set that I used, the model code, and some of the train test results, which is just a pretty standard ML workflow. And then lastly, I think the cool part is the metrics on runtime performance that I was able to scrape from this and just shows how quickly one can develop a model using these awesome pieces of hardware. So um, just a quick note, there was some learning on the side of how to configure the hardware and software to work together properly. So with the machine that I was able to access, we have to get NVIDIA NVIDIA Toolkit 12.4. You also need to have a driver version, which is listed here. And unfortunately, the PyTorch version to work with this toolkit and driver wasn't a straightforward install. So we had to do a little bit of digging on some forums. At the end of the day, you can build from a wheel this for CUDA 12.4 toolkit. So yeah, straightforward Anaconda install was not possible, but they should be rolling out a release sometime soon. So you have to go through some of this just to get the PyTorch model to be able to find the GPU. And so once you get over that hurdle, um, uh, you know, you're kind of ready to train. But before I go into that, I wanted to just show this NVIDIA system management interface. This is really cool. Um, so you're able right now, nothing when the screenshot was taken, nothing was running, but you can see it has the ability to list out the different processes the GPU is running, gives you a process ID. It also gives you the memory usage, and you can see there's a whopping almost 100 gigabytes here of, um, of memory. And here it says here we have the GH200. So yeah, some cool tools that one can use. The data set that I used here was a fairly simple data set. With a model that's going to be this big, we're definitely going to see some overfitting. But this was just the intent of this video is more to understand how to use the GH200 rather than build out a robust model. So I use this relatively small data set here for Microsoft Cocoa, 5 different classes of images split into 75% training and 25% testing. And so here are just some examples of the images. The classes I had were aircraft, buses, cats, dogs, and pizzas. And these images were resized to 64 by 64 by 3 channels. And one of the cool things in a GPU is that we can take advantage of all the parallel matrix multiplication. And so when you build these data loaders, it's awesome that you can set your batch size pretty high because there's a good amount of memory. And then we can also take advantage of the parallel workers. So what this workers does here is as your model is doing one forward and backward propagation paths, it's prepping the next batch to basically be ready so that when that previous gradient update is done, you're not waiting on IO to load up a new data set. So it's just one way to leverage PyTorch to speed up your training. But definitely batching has a huge impact in terms of speed and also model convergence. The model code is mostly from the ViT paper from Google in 2021. I wrote most of the code here in graduate school, but it's just to say that it follows the the outline of what these authors had provided in 2021. And so yeah, actually, this is a training result, but I actually want to show um, what the launchpad interface looks like. So let's dive into that. Um, so again, here down here in the left corner is the Nvidia SMI toolkit. So one can just type in Nvidia-SMI and oop, it spelled it wrong, Nvidia-SMI, and you can see um, that there is nothing running. There's no process ID, but let's go ahead and kick off a fairly large model run. So I have all the training code here in models.py, so we'll kick that off. And this is just some printouts from the data loader. Okay, it says the CUDA GPU is available. Fantastic. And then this is a pretty big model. If we count carefully, there's um, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2.8 billion parameters. So really big. And just to show why this is so big, um, we're taking a 64 by 64 by 3 channel image, um, building 16 patches in it. So each patch is about 16 by 16 in a 64 by 64 by 3 channel image. We have an embedding size of 512. So these matrices that are used to generate the query key and value vectors get pretty big. And then we're also doing eight um, 8 encoders, 8 transformer blocks basically in this vision transformer. And then we're also doing multi-headed attention. So there's a lot of matrices, and that's why it gets so big. So here we see the model training start already. We're through basically 2 epochs, so that's really fast. So we'll let this run. I have set it to 20 epochs, and then we'll come back and see how fast this model ran. So, and one thing that I wanna, I think, show here is let's go ahead and pull up the NVIDIA SMI tool while the training is going. So now we see we have a process ID. It's using Python 3 and it's using about 56,000, so 56 gigabytes of GPU memory. Um, so that's what's showing here. It looks like we have about 100,000 gigabytes available. So I'm not sure what the 480 gigabyte um, uh, text is here, um, but it seems that a 3 billion parameter model is uh, training fairly quickly here. And then it's cool that we can see the temperature. Looks like it's not reading a fan, but also shows the power usage. So we can see that at least at the time that I ran this NVIDIA System Management Interface tool, that it's using 700 or 276 watts out of a possible 900 watts on this machine. All right, so it looks like the model training has completed, where and we did a little benchmark here. So we can see that the total time to go through 20 epochs on this 3 billion parameter model in terms of training was only 12 and a half minutes or so. And basically the testing was very quick as well. So that was only 3 seconds. And so just under 13 minutes clocking in for end to end in training this very large 3 billion parameter model. So that just points to the power of these uh, awesome Grace Hopper 200 GPUs. And let's just go here. I'm not sure if I missed anything else that I want to talk about. Yeah, this is the same loss curve over training. Again, with the batching, it really helps convergence. We didn't really need to go through 20 epochs here, but I just wanted to go through it for the purposes of showing this hardware run fast. These are the test results. Again, not great, about 50% accuracy overall. But again, we're overfitting. We have a very small data set and a very large model. So this is expected. And this is a screenshot of the of a of the performance analysis. So there you have it. You can sign up for the Grace Hopper 200 GPU. It's a beast using NVIDIA's launchpad. And if you have any questions about these GPUs, how to run them, or set up a model, feel free to reach out. Thank you. Bye.